Okay, as soon as I start reading this, I have a sense I'm going to just make up a number for the items in the box, right? How many items are there total? So that's arithmetizing, right? We do that whenever we kind of seem to be missing some crucial piece of information in the story that they don't really ever ask us to solve for here. So they're not asking me for a number of items at any point. They're always talking relationships, right? Percentages. So why not just have a number? It makes it easy. So that way I can say, okay, there's 100 items in the box. 37% of those items are green. So very quickly, 37 green items. Great. Nice and easy. Of those, 37% are also rectangular. So be careful here, right? It's not another 37 rectangular items. We're narrowing it down. Now we're not thinking of 37% of 100. We're thinking of 37% of 37. So here's where I'd kind of go to my open formulas and say, okay, my original, or open, right? My original value is now 37, right? Where of those, of the green items in the box, what 37%, so 0.37, are this, rectangular. So now I'm going to the calculator. 37 times 0.37 is 13.69. Okay, so 13.69 are rectangular. Of the green rectangular items, again, we're now narrowing it down. The original is a smaller number. 42% are also metal. So now, again, the original is the smaller number, 13.69, and then, okay, 42% are metal. So we have another kind of smaller group. So 13.69 times 0.42 is 5.7498. Okay, so 5.7498 are metal rectangular green items. Very specific. But that's it, right? Which of the following is closest to the percentage of items in the box that are not rectangular green metal items? Now, many of you would pick this answer if it were an answer. And for some reason, it's not. And I think that makes this question considerably easier because there's no tempting choice. So maybe, I don't know, maybe some of you might pick B here because it's kind of related. I can see how that number, 57.5, would kind of show up. But because we arithmetize, it's not tempting to me. I'm not randomly moving decimals around. Maybe if you were taking 37% of 42% without having a starting value, that becomes more tempting because now you're kind of deep into percentages and maybe you're starting to move decimals around in weird ways. But yeah, I don't know. There's no trap answer here. So all I'm doing is I'm saying, okay, these were the green rectangular metal items. We want the ones that are not those things. So I'm just going to subtract this from 100, and I can kind of just estimate, right? It's 100 minus 6 is roughly 94, so it's going to be C. But yeah, 100 minus 5.7498 is 94.2502. So that's it. I don't know where choices A and D come from. If you got one of those, let me know. I'm curious what you did to get those. Maybe you took another 37%. Somewhere you did too many 37s. I don't know. But regardless, it doesn't mathematically make a difference if I make up the number of items here and just say there's 100 items. It's not like I'm really doing any different math if I have a number. It's just easier to think about, right? I can think about actual objects instead of this kind of empty relationship thing. So I do think something like choice B is more tempting if you're not arithmetizing here. Let me know. Why'd you pick it if you picked B? I'm curious. Anyone who got it wrong, tell me in the comments what you did. I am curious, but I think this question sets itself up pretty nicely. So it's very hard to get wrong. So I am curious. I really think it would be a very different question. We'd be having a very different conversation if 5.75% were an answer, because then it's not so much that you got a percent problem wrong. You got a reading problem wrong, right? You didn't read the not that's underlined, but some people don't read that. It happens all the time.